It says the scatter diagram shows the price and age for each of 10 cars, same make and same model. Okay, now the first thing that you should do straight away is what? What am I doing here?
Seeing how much the squares are worth.
Brilliant, seeing how much one little square is worth. So I've done that by looking at from 0 to 2000, seeing how big that jump is, which is 2000. And then I've done 2000 divided by 10. Why divided by 10?
There's 10 squares.
Good. 10 little squares go into there. Okay? So that told me, 2000 divided by 10 told me 200, which tells me the size of one little square. Okay? So I wouldn't recommend going on much further than that before you even start a question. Know your scales so you don't accidentally fall for the incorrect thing. The next question says, write down the price of a new car. So how old is a new car? How many years old would a new car be?
0.
0, well done. So you're actually looking on the axes here. So you're actually looking at this chap here. I'm trying to zoom in so much so you can't quite see what the answer is. The common wrong answer here would be 6,200 because, see 6,000 is by here. You go 6,100, 6,200. So why is that incorrect?
Because each of us
Fantastic. We just found out that each little square is worth 200, so it'll be 6,200, 6,400. So you'll see just by the side there, 6,400. Okay. The next question said, write down the price of the oldest car. So I'm looking for the one that's like furthest down the axes. So 4, and there's only one there, so it's got to be that one there. So it's just reading off that value. So I wrote it off as 2,000. Okay. The next one says, draw by eye a line of best fit. What does by eye mean when we're drawing by eye a line of best fit? Any ideas?
Well, like the most you can get in the line and the same as on the
You
line.
don't need to worry so much about getting the most in line. That's something we look at in science more than maths, but good knowledge from that nonetheless. Basically, if you're to draw a proper line of best fit, you'll draw like what is called a mean point. And then you'll put a circle around it, your line must go through that. You've not been taught that because it doesn't come up in WJEC. Okay? So you don't need to find the mean point, you just need to look at drawing a line which roughly has the same amount of points each side of the line. So I've got 3 here, 1, 2, 3 here, and then I've got, what, about 1, 2, 3, 4 on the line, roughly. Okay? So that line would be fine. Maybe it could be a little bit better, but I don't think we can make it drastically better. Okay? And the idea of that line is it will help you in the final part when it says, estimate the cost of a car that is 2.5 years old. So 2.5 must be in between 2 and 3. So I've drawn a line at 2.5, got up until I hit my line of best fit, and then I've gone off and written that value there. Okay, and it went straight in the middle between 4,000 and 2,000, so I knew it must be 3,000. Okay? Good, you just move it. So you've got 4 types of what we call transformations. So we've looked at enlargements in the past, we've looked at rotations, reflections, and the last one is translations. Okay? Now enlargement's pretty obvious, it does what it says on the tin, enlarges things, although ironically they can get smaller if you have like a scale factor of 1/2, for instance, make it half as big. Rotations, again, do what they say on the tin, they spin things round. Reflections, things look at each other, mirror images and stuff like that, mirror lines. Translations literally just moves it so it looks exactly the same. Okay? And it tells you what to do. It says move it 6 to the right and 3 up. The way that I do it is I pick a corner, and it does not matter which corner you pick. I picked the bottom left corner, you could pick any of them. Okay? I've counted 6 to the right, and then I've gone 3 up. Okay? So altogether, I've got that corner by there. Now what you should do is you should do the same for every single corner. But what I do is I tend to draw the first corner and then I just draw what that shape looks like. I know I'm that bottom corner there, so I just drew a straight line going across, then up 5, then back 3, and then down 5. Okay? So where it says y equals 6, y-axis, finger on 6, draw straight across. Every value here, if you go back and check what the y value is, it always comes back to being 6. The x value changes throughout the journey of that line. It goes 1, then 2, then 3. But the y is always equal to 6. Okay? Now, in terms of being a reflection, the way I do it is I look at this corner here and count how far away it is from the line. So it's 2 squares away, so that means it must be 2 squares away this side. This one here is also 2 squares away. And then this one here, 1, 2, 3, 4, 5. So I count here from 5. 1, 2, 3, 4, 5. And then I just join the dots up. So we're given like a time sheet of what this guy Aled does on his way to the gym. So 8 o'clock he leaves home, 8:15 he stops at a friend's house, getting prepped, getting pumped up for the gym, can't wait. 8:36 he leaves his friend's house, so he stays there for a full 21 minutes, doing something. Then he arrives at the gym at 9 o'clock, leaves the gym at 11, and then he arrives home, okay? We're told that Aled's friend lives 2.5 miles away from his house, so I'm going to be having to deal with scales of this pretty quickly as well. And then the key word here for me, I probably should have highlighted this as well. Let me just change the size of this highlighted thing. Do that or not? I probably should have highlighted further here. It's important that further 3 miles, that's going to be very important in the next bit. Okay, so if I look just at the side here, what I tend to do is go and put in like the middle markers as well, because you may well find they help you. So I've added in the 3, I've added in the 5. I could have added in 1 here as well, I suppose. Okay, now we know that his mate lives 2.5 miles away from him. Oh, and this thing's really important as well. This graph is measuring the distance in miles from Aled's home. Okay, so because he lives 2.5 miles away, and he gets there by 8:15, I'm going to plot that point. So I'm looking for 2.5, and I'm looking for 8:15. Okay, so here's 4, here's 2. So I knew 3 was in the middle. So then in the middle of 3 and 2 is going to be 2.5. Yeah? So there's 1, 2, 3, 4, 5 little squares there. So half of that is 2.5. So I plotted that at 2.5. And the way I knew that was 8:15 was here is 8, here's 9. In the middle, that must be 8 and 8:30. So in the middle of that must be 8:15. So it's this first like sort of mini sort of line thing here. 5 squares in by here. And it's just a straight line that we do to draw that and connect it up. Okay, the next thing that happens, if we go back and read from the table, it says that he stays at his friend's house until 8:36. Okay, so what I've done by here is I've worked out the scale. Now, it's not quite the scale that it says here. It says 8 to 9. How have I got 60 there? Where's 60 come from? That's an hour in minutes, isn't it? Okay. Now, the reason why I changed that into minutes was because everything in this table here was in minutes. It said like 50 minutes to 36 minutes. So what I've done, there's 2 ways of doing it. I've done what was sort of given to me within that question, which had 1 hour. But some of our other class, what they looked to do, they said, well, we know that's 8:30. So 10 little squares into 8:30, that's 30 minutes, 3 minutes a square. I've done 60 divided by 20 because there's 20 little squares up for 1 hour. And it still gives exactly the same answer. So it's whichever one you think makes more sense. Okay? But I found that 1 little square is worth 3 minutes. So from 8:15, which was this point here, this is 8:30. This must be 8:33. So this is 8:36. So 2 little squares on from 8:30 is 8:36. And that's a straight flat line the entire time because he's staying at his friend's house, so he's not getting any further away from home. He's not getting any closer to home. He then goes to the gym at 9 o'clock. Now the gym, this is where that word further, very good. The common misconception would be to go to like 3, which is just by here. But it's a further 3 on from the 2.5 miles, so you need to go up to 5.5. So I did exactly the same technique again. I said here's 6, here's 5, 5.5's in the middle. So I plotted that point and joined it up with a straight line. Okay. Now your marks have come in so far. We've got 1 mark for doing that 15-minute journey, 2.5 miles, and then your next mark comes from the flat line and the connection up to 5.5. Okay. Your next mark comes in. How long does he stay at the gym for? Can you remember? Is it 2 hours? It says in the table it's just above. I can't see it though. I think it's 2 hours. You get another mark for joining that as a flat line, because as he's at the gym, he's not getting any further or any closer to home, so he's just flat lining there. Okay? But then what happens at 11 is he finishes at the gym and he goes home. And he gets home by 11:30. So going back to this axis, in terms of his distance from his own house, as he's going back home, obviously he's going to be getting closer and closer and closer to his house. So your final graph should look something like that, where you get back at home at 11:30, and then you're no miles from your house because you're back at your house. As we're trying to find speed, we are covering the speed here. So that leaves us with distance divided by time. Now, in the question here, look, it says miles per hour. So just be very careful with this next calculation. It's got to be the miles divided by the time in hours. And we knew it took 30 minutes. It said 11 to 11:30, isn't it? 30 minutes. How much of an hour is 30 minutes? Half. So it's got to be 0.5 hours, okay? So when I've written it, I said speed equals 5.5 miles divided by 0.5 hours. As soon as they see that, you're getting a mark. Change the lightsaber because it's annoying me. You get a mark for doing that. And then how many 0.5s fit into 5.5? Well, there's two ways to do it. You can do the trial and improvement way if you want. 0.5, 1, 1.5, 2. It's going to be a bit of a pain, but you'll get there eventually. Not 10, you're very close. 11, yeah. If you recognise that 0.5 is a half, if you divide by a half, you actually times by 2. If you didn't know that, don't worry, we've got that 0.5 way of working. Okay? So the answer is 11 miles per hour. If you did it as 5.5 divided by 30, you'd be working out your miles per minute. Which is a weird way to think. The speed limit on motorways in miles per minute. Okay? The way that I started solving that was I looked for the smallest x, which was 2x, and I took 2x from each side. Okay? 6x take away 2x is 4x. That minus 7 isn't going anywhere at all. And that is equal to 21. And that got me one method mark for just picking the smallest x and getting rid of it. The next thing I did, I thought, right, I want to get rid of this minus 7 because it's not physically attached to the x. That 4 is, so I'm going to leave that 4 there for the time being. So to get rid of minus 7, I'm going to add 7 to both sides, which I did. And I got another method mark. I got 4x is equal to 28. Now that 4x really means 4 times x. We don't write the times, so it looks like an x, as we went through earlier in the week. So I need to do the opposite timesing by, which is dividing by, and I divide by 4, and I got the answer 7. If you got the answer 7, regardless of your work, you will get all 3 marks, but it must state somewhere x. 7. If you get that bit wrong, and you've done the steps, then you've got 2 out of 3 marks anyway. Okay, so that's why we say show your workings. You're factorising, you'll either get this mark or you won't. It's finding the biggest number that goes into both 24 and 3, which is 3, and then it's 3 brackets 8x plus 1. And the one underneath, there isn't actually a number that goes into both. There's a letter though, x is in both, so we take x out. Highest power of x that goes into both of them is x, because this hasn't got a power here. So then x times x makes x squared, and x times minus 6 is minus 6x. Expanding, I thought this was a nicer 2 marks than the last 2 marks. This becomes 2x times x cubed, which is 2x to the power 4, and plus 12x, and you've got 1 for each of those numbers. And then another solving equations one, I don't know why they put that one in as well as the one at the top, but they did. Get rid of the plus 15, take away 15 either side. That leaves me with x over 3. The over means divided by, so I times both sides by 3, so x equals 30. Okay, so this question is asking you, so think of it like playing Monopoly. It says, Ros and Simon are throwing a fair dice, calculate the sum of the 2 numbers, or calculate the probability that the sum of the 2 numbers obtained is 4. Okay, so basically, like playing Monopoly, what are the chances I get 4? So we need to think of the ways I could roll the 4. And the way I've done it through a 2-way table to try and get some idea of the different ways I could make 4. So what I've done by here is I've written out the first dice and the second dice, and then I've added the 2 numbers together. So if on the first dice I got 1, 2, 3, 4, 5 or 6, but on the other dice I got 1, then I could have got 2, 3, 4, 5, 6, 7, etc. Okay? Now you'll notice I didn't bother filling in the rest of this table here, and the reason why I didn't is because it clearly went way above 4. So I thought, what's the point? It's a waste of my time. So in terms of the different ways that I could make 4, I could get this one here, which is a 3 and a 1. I could have got a 2 and a 2, but they're both on 2. There's only one way I can make that, which is 2 on one dice. And because that dice is already on 2 and the other dice is already on 2, we can't have it the other way round. And then this one here, which was a 1 and a 3. Okay? And I felt by drawing it out like that, it's quite obvious of how I got 3 out of 36. But people do make mistakes on this sort of question. They look at it and think it's 2 out of 12. They think 6 on one dice, 6 on the other dice. That's 12 different outcomes. But hopefully you can see from this table that there's way more than that. So when I've got this dice here, I can get 1, 2, 3, 4, 5, and 6. On the other dice, I could have got 1. So I could have had 1, 2, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. But I could have had 2, 1, 2, 2, 2, 3, etc. And that goes all the way down to 6. There's actually, the amount of outcomes is this number of outcomes, so 6 outcomes by 6 outcomes, 36, because 6 times 6 is 36. Okay? So I've worked that out that way, and I said 3 out of 36. Now you'll notice it was 3 marks. And one of the marks, you get an S1, which is called strategy, for doing some sort of correct strategy where we're trying to pick numbers that add up together to make 4. But the way, if you don't do this table, what you might get confused with, you might look at it and think, well, the way I can make 4, I could get a 1 and a 3, I could get a 2 and a 2, I could get a 2 and a 2 the other way around, but you can't because you've already had 2 on this one. So that's why I prefer doing the table. But I could get a 3 and a 1, that makes sense. So this one doesn't really work, which is why I prefer doing the two-way tables. I think it makes it more obvious that it doesn't work. Okay? But if we got that mark, and the ones that we've done so far we feel we fully understood, we're now on 26 marks, which means we've achieved the C grade. One underneath. Okay, so it's important that you read the instructions to this. Now, it's very, very easy to get 2 marks here. The median is 6. Median means middle. So the middle number is 6. So out of those 7 cards, you've got to put 6 in the middle. The range is 8. We'll come back to that one. That was maybe not quite so easy. But the mode being 3, that makes that one very easy as well. What does mode mean? Most common. So there's got to be at least 2 3s. It's got to have the most of them has got to be 3s. Now, I put in the 6 and got that mark straight away. And put in the 2 3s. So as soon as you put 2 or 3 3s, you're going to get another mark. But if you put in another 3 in place of this one here, you're told that these are single-digit numbers. And what number take away 3 gives a range of 8? And the answer is 11. 11 take away 3 would be 8 to get that range of 8. 11 to go in there is not a single-digit number. Okay? So I had to think, what single-digit numbers can I have a difference of 8? So 9 take away 1, and that's it. I suppose you could have 8 take away 0, but I'd argue that 0 isn't a single-digit number. I'd just say 0 is nothing. Okay? So 9 there, 1 there. That got a mark for getting the 9 and the 1 either side. These two here, because they were single-digit numbers, could have been 7 or 8. They couldn't have been 6, because then I would have had 2 6s. I've already got 2 3s. I'm trying to make 3 the mode. It could have been 2 7s for the same reason. It could have been 2 8s for the same reason. So it had to be just a 1 7 and a 1 8 and then a 9. Okay?